Hi everyone. TRIG is a kind of amazing Sherlock Holmes style method that allows us to fill in the blanks when we only have limited information about right angle triangles. A right angle triangle is either exactly half a square or exactly half a rectangle cut from one corner to the opposite corner. Just to recap on a little Pythagoras, whatever the side lengths are of a square, the diagonal is root 2, or about 1.41 times as long. To find the diagonal length in a rectangle, we square one side, in this case 3 squared is 9, then square the other side, 4 squared is 16. We add those two results together, 9 plus 16 is 25. Then we find the square root of that number, which is 5. If you want to know the height of something without having to climb it, look to the top of the object at an angle of exactly 45 degrees from the ground. How far you are away from the object will be how tall it is. The distance of the diagonal will be this length times root 2. This only works for 45-degree angles, so TRIG allows us to fill in these blanks for other right triangles. Before we can start, we need to know how to rearrange these simple equations. If A equals B divided by C, what does B equal? And what does C equal? We can substitute A, B, and C for numbers that will produce a correct answer. If we want to make B the subject of the equation, 40, we have to multiply A, 20, by C, 2. So B equals A times C. If we want to make C the subject of the equation, 2, we have to divide B by A, so C equals B divided by A. To remember how to find C when A equals B over C, think divide back. C equals B divided by A, divide back. To remember how to find B when A equals B divided by C, think down with the good times. We have to go down from A to C, down with the good times. B equals A times C. Okay, a different equation. A equals B times C this time. What do B and C equal? We'll use the same method again. Remember to only substitute numbers into the equation that will still work. To make B the subject of the equation, 3, we can only do that using the other two numbers by dividing A by C. For C, we have to divide A by B. Simply cover over the one you want to make the subject of the equation in this triangle, and you're left with the correct answer. Okay, we're ready to start. We'll use TRIG when we know one of the other angles and at least one of the side lengths. Remember that one of the angles is always 90 degrees. In this case, we'll need to find one of the sides, x. Another time we'll use TRIG is when we'll know two side lengths at least, and we need to find a missing angle. This little square in the angle means it's 90 degrees, a right angle, so the other two angles are complementary, meaning they must together add up to 90 degrees, as there are 180 degrees between all three. That symbol we just saw is the Greek letter theta and indicates this is an angle we either know or need to know. Okay, let's work through a question together. Work out the height of the tree without having to climb it. Well, we can easily measure the distance from the tree by using a tape measure or a wheel. Let's say this distance is 10 meters. We can measure the angle from the ground to the top of the tree in real life using something called a theodolite if you're curious. We measure this as 31 degrees. The first thing we need to do now is to label the sides. The longest side, and it's always opposite the right angle as well, is called the hypotenuse. We don't know the hypotenuse, and we don't actually need to know the hypotenuse in this case. The side opposite theta, remember theta is the angle we know or need to know, we know the angle here, is called the opposite side. and it has a length of x. This means that we need to know this length. The side that forms theta with the hypotenuse is called the adjacent side. In our triangle, it has a value of 10. There are 3 types of tools in trigonometry, called sine, cosine and tangent, shortened to sine, cos and tan, with 2 variations of each, depending on if we want to find out a side length or the angle theta. If we need to find theta, we refer to the functions as the inverse sine, inverse cosine or inverse tangent. Alternatively, we can refer to these angle finding functions as arc sine, arc cos and arc tan. On most calculators, you'll need to press the shift button before pressing the sine, cos or tan buttons to access these. So how do you know when to use each of the trig tools we just spoke about? Well, the trig tools actually relate to theta. This will make more sense soon, I promise. We know which one to select depending on which of the 2 sides we are working with. When I say working with, I mean we either know or need to know. Don't worry if this is a little unclear at this point, it will make sense by the end of this video. It's important to commit these to memory. Sine theta equals opposite divided by hypotenuse. Cos theta equals adjacent divided by hypotenuse. Tan theta equals opposite divided by adjacent. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Say it yourself a few times. I can guarantee it will come in really useful. Okay, let's write down everything we know about the triangle. Theta is 31. We don't know the hypotenuse, and we don't need to know it. We need to know the opposite side, the height of the tree, so we can forget about the hypotenuse from this point. We don't know the opposite side, but we do need to know the opposite side. That's exactly what the x means. The adjacent side is the distance from the tree, which we measured to be 10. So here's how we know which tool to use. Are we working with the hypotenuse? By working with, I mean do we know it or do we need to know it? No. Are we working with the opposite side? Yes, we need to know it. We're working with the adjacent side? Yes, we do know it. Next, let's write down all our trig tools. See how SOHCAHTOA comes in useful. To use the sine tool, we need to be working with the opposite and the hypotenuse. We're not working with the hypotenuse, so we can cross that out. To use the cosine or cos tool, we need to be working with the adjacent and the hypotenuse. We're not working with the hypotenuse, so we can cross that one out. To use the tangent or tan tool, we need to be working with the opposite and adjacent sides. Bingo. Now that we know we're working with the tan tool, we need to decide which variation to use, tan or arctan. Well, we'd use tan if we were trying to find a side length, and arctan if we are trying to find the angle, theta. As we're trying to find the height of the tree, which is the opposite side length, we're going to use the tan function, and not the arctan function. The next step is to write out the tan tool as an equation. From this point on, we'll write the equation with theta next to the trig tool, like this. We can now substitute our known values into this equation. Theta is 31, so we write tan 31. The opposite side has a value of x, indicating that we don't know it, but we do need to know it. Divided by the adjacent side, which we know is 10. Hopefully at this point you can see why we looked at how to rearrange equations at the start of this video. Being able to do this empowers us to make x the subject of the equation, allowing us to solve it much more easily. Before we rearranged the equation, tan 31 was a, x was b, and 10 was c. Do you remember how to make b the subject of the equation when a equals b divided by c? Looking at x, we have to go down from tan 31 to get to 10. Down with the good times. Because we're going down from tan 31 to 10, we're down with the good times. So x equals tan 31 times 10. You might be thinking, what does tan 31 actually mean? Personally, I find it fascinating how these functions are derived. You can look it up, we won't go into it in this video, but if you put tan 31 into a calculator, you'll get a result. You'll need a scientific calculator or an app on your phone. Tan 31 comes out at this number here. If we multiply that number by 10, we just have to move the decimal point one place to the right to multiply by 10. And we can then round that to 6.01. Looking at our triangle with the adjacent side of 10, it looks like the opposite side should be 6.01, and if it feels right, it probably is right with trig. Okay, let's try another question. Find the side length x. First thing to do, the hypotenuse is always the longest side and it's always opposite the right angle. X is opposite theta, so it's the opposite side. We don't know the value, but we do need to know it, hence it's labelled with a value of x. That just leaves one more side, the adjacent side, which forms theta with the hypotenuse. We don't know it and we don't need to know it. Okay, next step, decide which tool we're going to use. Will it be the sine tool? Are we working with the opposite and the hypotenuse? Yes, we are. Let's just check. To use the cosine tool, we need to be working with the adjacent side, which we're not, so we can cross that one out. Same for tangent, so we can forget about the cos and tan tools from this point. The next step is to write out the sine tool as an equation with the theta symbol after the tool. We can now substitute in our known values before making x the subject of the equation. Again, we have to go down from sine 35 to 17, so we're going to multiply sine 35 by 17 to find x. Putting this into a calculator, the result we get is 9.75. Have a look at the triangle. The hypotenuse has a length of 17, so the opposite side looks like it should have a length of 9.75. Again, if it feels right, it probably is right. This time we need to find the angle theta. We've been given two side lengths. After labelling the sides, we can see that we've been given the hypotenuse and the adjacent. By using SOHCAHTOA, we can write out all of our trig tools to find out which one we need to use. Remember, we're working with the adjacent and the hypotenuse. You can probably see at this point which tool we're going to use, but let's just go through them anyway, just to make sure. We'd use the sine tool if we're working with the opposite and the hypotenuse, but we're not working with the opposite, so we can forget about that. Cosine tool would be if we're working with the adjacent, which we are, and the hypotenuse, which we are, so we know it's going to be the cosine tool. We can forget about the tangent tool because we're not working with the opposite side. Let's write out our tool as an equation. Substitute in the known values, but remember that we're going to be using the arc cosine tool because we're trying to find an angle, not a side. You'll probably need to press the shift button on your calculator before pressing cos to access the arc cos variation of the cos tool. If you press 24 divided by 46 on your calculator and then run that result into the arc cos tool, that comes out at 58.6. That's degrees. Looking at our triangle, theta looks like it should be 58.6 degrees. Great. We'll try one more question where we have to find theta when we're given two or more side lengths. After we've labelled the sides, write down our toolkit. I wonder at this point if you can work out which tool we're going to use. The easiest way to do this is by process of elimination. We don't know and we don't need to know the hypotenuse, so we can just cross out the two tools which will use the hypotenuse. The sine and the cosine tools. That only leaves the tangent. Again, don't forget to include the theta symbol. Substitute in their values. We don't need to rearrange the equation when finding the angle using the arc functions. Just punch this in. And the result we get from this is going to be. Don't forget to include the degree symbol if it's not already on the paper. Your turn to have a go at these on your own. All the best for now and stay lucky.